second part of our revision for module 5. Actually, module 5 is divided into two parts, telling whether the equation is a function or not, and telling if it is linear or not. Let's start with number 1, which is function or not a function. Actually, let's divide our page into two halves. This one here is a function, and the second part is not function. What is a function? It is a relation between inputs, which are some numbers, for example, and the outputs. And each input should only have one output. Mister, can they have the same output? Yes, but again, each input must have one output. Each one of these inputs must be having one arrow coming out of the input. I only care for the input. So for example, if you have here 2, 1, 7, and 2 has an image which is 4, 1 has an image which is 4, 7 has an image which is 4, as long as each input has one output, so we say this is a function. Here 7, 5, 4, 1, 3, 2. Again, each input has one output, one arrow coming from the input, so this is a function. When is it not a function? Again, let's draw our diagrams. Here is the input, and here's the output. Very good. Take care. I have 3 inputs, 2, 3, 5. And here you have 3 outputs also. Let's say 1, 2, 4. In the non-function graph, the question will be looking like this. The 2 is going for 1, and it's also going for 2. So the input 2 has more than one output, so this one is not a function. Why? Because the input has more than one output. Very good. What if it is something that's looking like this? Input and the output. Here's the input, 3, and here's the output, 1, 2, 4, 7. And the input 3 is going for 1, going for 2, 4, and 7. How many outputs? More than one output? Not function. 3 was 1, 3 was 2, 3 was 4, 3 was 7. It has more than output. This 3 has more than one output, so it is not a function. Very good. Mister, can this work with graphs? Yes. Look, the function will be looking like this, something that looks like this, okay? But the not function or the non-function is something that's looking like this. Mister, how can I tell? You will draw a vertical line test with your pencil. Draw a vertical line with your hand. If it hits one point, so this is a function. If you draw a vertical line and it hits the blue curve in more than one point, here in 2 points, so this one is not a function immediately. So how I do this? With the vertical line test. Very good. Mister, if it comes as a table, input and output, you will have 3, 2, 2, 1, and here you have 0, 1, 4, 5. Take care. The same input is having the output 1 and 4. So the 2 is going for 1, and it's also going for 4. So this one is not a function. So we can put this one here in the non-function area. If the same thing here, if I want to show you when this one can be a function, the input cannot be repeated. So instead of having 2 again, you might have 7, and 2 was 4, 3 was 0, 1 was 5, 7 with 1, every input has one output, and he might put this in a table and it doesn't matter. So again, each input must have only one output, so this one can be a function. Very good. Mister, is there anything that can tell me whether it's a function or not? Yes, it might come like a graph. It looks like this. If you have some points on this graph, like a dot plot, and again another graph, something that looks like this. If you draw a vertical line test and it hits 1 point, at each one point, it hits also 1 point, so this is a function. But here, look, here it hits 1 point, okay, 1 point, okay. But here, when you draw a vertical line, how many points does it hit? More than 1 point, so this one is not a function. Very good. So now we are almost done with telling whether it's a function or not. What if he is asking about is it linear or non-linear? Briefly, linear, straight line. Non-linear, something that is not a straight line. Very good. So let's break our page into two parts, either linear or non-linear. Briefly, the linear is straight line. The non-linear is something that's a curve or curvy. Very good. So the question is, how can I tell if it's a graph? It's very easy to know that this is linear and this is not linear. But if it is an equation, it should be easily written in the form y equal mx plus b. The non-linear, I cannot write it in the form y equal mx plus b. I cannot write it in this form. So let's see. If y equals 3x, it is similar to y equal mx plus b. Here, if you notice, the power is empty. The power is 1. So this is linear. Y equal x power 2. Whenever the power is different than 1, so this is non-linear. If it is something that looks like this, y equal square root x. Again, this is the same like x power 1 over 2. So these ones are non-linear. Why? Because the power of x is different than 1. Type, Mister, if it is x plus y equals 7, what is the power of the x? 1 or empty? So this is linear. What if it is y equal 1 over x plus 7? Take care. We have taken in quarter 1. 1 over x is the same like x power negative 1. So the power is different than 1. So this one also is non-linear. Very good. What if it is y equal 3 over x plus 4? Again, the x is in the denominator, so this is non-linear. Okay, so whenever you graph this, it will not be a straight line. Okay, very good. So let's start our questions. Module 5, we have just talked about this part. Each input has one output, so yes, it's a function. If an input has more than one output, so this is not a function. This is what this one is, not a function. Very good. So determine whether a relation is a function or not. Take care. The negative 3, one output, one output. The 9, the input has how many outputs? 2 outputs. So this one is not a function. Why? Because, let's fix this together. Because the input, or because, let's say, because the input, let's fix it together. Because the input 9 has more than one output. Very good. We will do the same idea for all the choices, not function, because the input, whatever the input, here the input was 9, has more than one output. We will fix this in all the question because, okay, very good. So question 2, determine whether this relation is a function or not. Take care. The input 5 has one output, one output, one output, one output. So it is a function because each one of the input has one output. Very good. Here, take care. The input is repeated. I only focus on the input. Whenever the input is repeated, this means that the 5 goes with 0, and it goes with 5, and it goes with 10, and it also goes with 15. So this one here is not a function. Why? Because the input 5 has more than one output. Very good. Here, is it a function or not? Again, whenever you have a graph, you should draw a vertical line test. 1 point. Draw a vertical line test. How many points? More than 1 point. So this one is not a function. Why? Because the input, what is the input here? The input is 1. Because the input has more than one output. Very good. And that's briefly function or not a function. In this graph, we want to know if it's a function or not. Again, draw a vertical line test to tell us that it's a function or not. How many points does it hit the curve? 1, 2. So this one is not a function. So we will say not a function because the input here 1 has more than one output. Very good. Complete the function table for the given function given. Y equal 5x plus 2. Whenever you input an x, you should get out a y. Very good. So, in the first part, y equal 5x. What is x? 5 is 5x plus 2. What is x here? Negative 2. So 5 times negative 2, negative 10, plus 2. Different sign, subtract. 10 minus 2 is 8. So the answer is negative 8. Again, the x now is 0. So y equal 5x plus 2. What is x? 0. 5 times 0 is 0 plus 2. So 0 plus 2 is equal to 2. Very good. Let's continue. What if I have the x is 2? So the y equal 5x plus 2. 5x plus 2. So equal 5 times 2, 10. 10 plus 2 is 12. Very good. So the answer here now became 12. Let's continue. Y equal 5x plus 2. I'm working with this function. 5 times, what is the x now? 4. So 5 times 4 is 20. 20 plus 2 is 22. Very good. Y equal negative x plus 8. Again, y equal negative x plus 8. What is the x here? Negative 5. Take care, negative and negative, positive 5 plus 8. 5 plus 8 is 13. So the answer is 13. Again, y equals negative x. What is x here? Negative 2 plus 8. Again, negative and negative, positive 2 plus 8 is equal 10. Very good. Again, y equal negative x plus 8. Substitute the x. So negative x plus, let's write it clearly, y equal negative x plus 8. So what is the x here? 1. So negative 1 plus 8, different signs, subtract. 8 minus 1, 7. So the y equals, again, negative x plus 8. What is the x here? X is 4. So minus 4 plus 8, different signs, subtract. 8 minus 4, 4. Very good. It is positive because the 8 is bigger than the 4. So we took its sign. Very good. And number 7. The amount of snow that falls during a snowstorm is shown in the graph. Where is the correct equation with the correct slope? The initial value is the b. Where does it start? Where does it cut the y-axis? It cuts the y-axis here at 8. So the b, or the initial value, is 8. So initial value is 8 in A or C. I eliminated B because the initial value is 18. So this one doesn't work, and this one also doesn't work. The initial value is 16. The initial value here is just 8. What is the slope? The slope will decide the correct answer. So m equals, let's take any 2 points, this one and this one, for example. 16, we say we have x and y. Remember, module 4, x and y. So subtract the y together. 16 minus 14. 16 minus 14 over the x together. 4 minus 3. What is 16 minus 14? 2. 4 minus 3 is 1. So the slope 2 over 1, which is 2. So here is the answer. The initial value 8 and the slope is 2. Excellent. Very good. Pause the video and try to solve this on your own. Very good. Actually, in this part, you can easily figure out the y-intercept. Is it 4? It is not. The line is not cutting the y-axis at 4, so it's not this one. Cancel A. Is it 7? No. Is it 8? No. So the only correct answer is y equals 6x plus 1. If you want to make sure, you can find the slope. Subtract, let's say, this point that has x 3 and the y is 19. X is 2, y is 13. Subtract the y together. 19 minus 13 over 3 minus 2. Excellent. 19 minus 13, 6. 3 minus 2, 1. 6 over 1 is 6, so the slope here is 6. That's the correct answer. Very good. In this part, this is the challenging part in module 5. Very good. The table shows the amount of flour remaining after baking loaves of banana bread. Assume the relationship between two quantities is linear. Find and interpret the rate of change and the initial value. Then write the equation of the function in the form of y equals mx plus b. Very good. So I want to get the slope, the initial value, and the equation. Mister, in the previous tables, the x was 0, and you would easily get the b, which is the y value. But here you do not have x is 0. So this is the challenge. Now, easily I can get the slope, y2 minus y1 over x2 minus x1. Pick any 2 points. I picked these 2 points. Subtract the y together. 16 minus 8 over, I start with 16, start with 2. 2 minus 6. What is 16 minus 8? Bravo, 8. 2 minus 6, negative 4. Divide. 8 divided 4, 2, but take care, it is negative. So the slope is negative 2. What is your equation? Y equal mx plus b. So I have just got the m, which is negative 2. Do you have an easy way to get the y and the x? Yes, any of these points. Let's pick this point again. X is 2, y is 16. Here, x is 2, y is 16 from the table. Plus, what do you still have? B. Multiply 2 times 2 with negative, so it is negative 4. Negative 2 times 2, negative 4. And you still have the 16 plus b. If you want to get the value for the b, solve for it. Negative 4 can move to the left, or you can say plus 4 right, plus 4 left. What would happen? Negative 4 would cancel with positive 4. 16 plus 4, 20. So the b is equal 20. Very good. Can you get the equation now? Yes, y equal, what is the slope? Negative 2x. Negative 2. X, the slope is negative 2. X plus 20. The initial value is 20, and that's it. Pause the video and try to do this on your own. Question 10. Very good. The table shows the amount of flour remaining after baking loaves of banana bread. Assume that the relationship between the two quantities is linear. Find and interpret the rate of change and initial value. Then write the equation of the function in the form y equal mx plus b. Very good. So again, the easiest thing is to get the m, or the slope, y2 minus y1 over x2 minus x1. So let's pick these 2 points, for example, and subtract. 235 minus 155, 235 minus 155 over the x together, 4 minus 2. Subtract 235 minus 155. 5 minus 5, 0. 3 minus 5 can't be 1. 13. 13 minus 5, 8. So here the numerator is 80. 4 minus 2 is 2. 80 divided 2 is 40. Very good. So the slope now is 40. What about the initial value, or the y-intercept? Again, my equation, y equal mx plus b. The m that I have just got is 40. What about the x and the y? Let's see any point. Let's pick, for example, 2 and 155. So the x here is 2, the y is 155. X is 2, y is 155 from my table, plus b. Multiply 40 times 2 is 80, 155 as it is. And you still have plus b. I want to get the b value, solve for b. 80 can move to the left with negative, or you can say minus 80 right, minus 80 left. Because it's positive, you just put the opposite sign. 80 minus 80 cancelled. 155 minus 80. Subtract 105 minus 0, 5. 15 minus 8, 7. So the b, or the initial value, is 75. So the equation is y equal, what is the m? 40. X plus b, which is 75, and that's it. Very good. 11. The Carnival Committee is considering 2 pricing options for tickets. Option A is shown in the graph, option B is shown in the table. Compare the function's initial value and the rate of change. Here we want to compare both of them. If you want to take 5 minutes break, you can go for a 5 minutes break, drink some water, and let's continue our video. Very good, welcome back. Now, in question 11, he wants to compare the slopes of the 2 options and also the initial value of the 2 options. Here I have the slope. I should get the m and the b for the first one, and I should also get the m and the b for option B. So option A, it's very easy to figure out the y-intercept, or the initial value, because it's cutting the y-axis at 12, so that is the 12. Very good. What is the m? We just use the rule y2 minus y1 over x2 minus x1. So 20 minus 14. Again, xy. Subtract the y together. 20 minus 14 over x2 minus x1. 4 minus 1 over 4 minus 1. What is 20 minus 14? 6. 4 minus 1 is 3. So 6 divided 3 is just 2. So the slope here is 2. And the y-intercept is 12. What about the second option? Here x is 0. At x equals 0, the b is equal to the y. The y-intercept is equal to the y. So what is the b, or the y-intercept? It is 8. Very good. What about the m? Subtract 14 minus 8, change in y over change in x. So the m is equal 14 minus 8 over 2 minus 0 over 2 minus 0. What's 14 minus 8? 6. 2 minus 0 is 2. What is 6 divided 2? Just 3. So the m is equal to 3 and the b is 8. So if you notice, slope of b is greater and the y-intercept of a is greater. So let's see the options. Option A, slope is greater. No. Option A, slope is less. Yes. Option A, slope is less, because this is 2 and this is 3. Option B, slope. Option A, initial value, option A initial value, is greater than option B initial value? Yes, because the 12 is greater than the A. The B is the initial value, so this is the correct answer. Very good. Question 12. Miguel and Joss set goals for cross-country training. Miguel runs for 6.5 miles per day until he meets his goal of 39 miles. So we have a competitor called Miguel and another competitor called Joss. Joss has slope and y-intercept, and also Miguel has a slope and the y-intercept. This is Miguel and this is Joss. Very good. So the question now is, when he says 6.5 miles per day, so this is the m, whenever you find the per something, so this is the slope, so this is 6.5. Until he meets his goal of 39 miles, so he set a goal which is 39 miles, and he's approaching this goal. Take care, whenever he approach his goal, so the slope is negative 6.5, because every day he gets closer to the goal, which is 39. So at the beginning it's 39, when he runs for 6 miles or something it becomes 33, and so on. So it is decreasing, so that's why the slope is negative. Joss' plan is shown in the table. Compare the function's initial value and the rates of change. Let's see together. Here this table, we agreed at x equals 0, the b is equal to y. So here the b is equal 45. Here is the b and it is 45. And what about the m? y2 minus y1 over x2 minus x1. 40 minus 45, the y together, over the x together, 1 minus 0. 40 minus 45, negative 5 over 1, which is negative 1. So the slope here is negative 1, here is negative 6.5. Which option is correct? Let's see. Joss' slope is greater than Miguel's slope. Take care. Which is greater? Negative 5 for Joss or negative 6.5, or the negative 6.5 for Miguel? Take care. You might say that the 6.5 is greater, but take care, it is negative. So the negative 5 is greater than the negative 6.5. So Joss' slope is higher. The m is the slope. So Joss' slope is greater. So either A or C. This one, Joss' slope is less, so this one is not correct. And what about the initial value? Here the B is 39 and here's the B is 45. So of course the 45 is greater, so Joss' initial value is also greater. So Joss' initial value is greater. This is the correct answer, which has the slope greater and the initial value is also greater. Very good. Determine whether the graph represents a linear or non-linear function and explain. To know from a table whether it's a linear or non-linear function, we look at the change in the y over the change in x. Look, this one is a linear function. This one is not a linear function because it's not a straight line. So if you notice here the rate of change, which is the m, negative 2 over 5 is the same like negative 2 over 5, the same like negative 2 over 5. So this one is linear. How do I know if it's non-linear? Look, 3 over 1. Is it the same like 5 over 1? No. So this one is not linear because the rate of change is not constant. Let's solve this. Is this a straight line? No. So this is non-linear because the rate of change is not constant. The rate of change actually is not constant. If you notice here, the rate of change is moving slowly, and then suddenly, out of the sudden, the rate of change became to be very high. This one here, straight line. So this one is linear because the rate of change is constant. If you want to find the slope at any point, it will be the same thing. So at any 2 points, it will be the same slope or the same rate of change. 15. Determine whether the table represents a linear or non-linear. How do I know? From 1 to 2 plus 1, 2 to 3 plus 1, 3 to 4, the change is just 1. 9 to 18, I added 9. How do I know? 18 minus 9, 9. 27 minus 18, also I added 9. 27 to 36, I also added 9. If you want to make sure that it's linear, divide. 9 divided 1, 9. 9 divided 1 again, 9. 9 divided 1, 9. So this linear because the rate of change is constant. What about this one? Plus 1, plus 1, plus 1. From 10 to 40, I added 30. From 40 to 60, take care, you added 120 because 160 minus 40 is 120. From this point, 30 over 1, is it the same like 120 over 1? No, this is non-linear because the rate of change is not constant. Excellent. In this type of questions, we look at the x in the denominator as if it is x power negative 1. We agreed that whenever the x is different than 1, so this is non-linear because the equation can't be written in the form y equal mx plus b, because this is x power negative 1. The power of the x should be empty or 1. Type x over 4. Mister, the x is in the numerator this time. So x, does it have a power? No. So it can be written in the form of y equal mx plus b. So yes, it is linear because it can be written in the form of y equal mx plus b. So briefly or simply, whenever the x doesn't have a power, this means linear. Whenever it doesn't have a power, but take care, it's in the denominator, non-linear, because x power negative 1 will not be a straight line. When you draw it, it will not be a straight line. Qualitative graphs, and this is the last part. I want to decide which graph represents the situation. So a plant grows steadily. I have growing first until it reaches its full height, at which time it stops growing. Which graph displays this relationship? Actually, this one here is growing, so this is number 1, and this one also is growing. Very good. But which graph represents the stop of growing? I believe it is this graph, which is graph A. So because here it stops, look, it's constant. So the correct answer is A. This one, does it have a growing? No, doesn't have the step 1 either, neither. Question 20. At the county fair, Grace took a ride in a hot air balloon. It was a tethered balloon, which means that the balloon stayed tied to the ground, so it didn't drift too high or too far. Grace floated up into the sky until the tether was fully unrolled. Very good. So step 1, he went up to the sky. She stayed up there a while enjoying the scenery. She stayed up a scenery and then she came back down. So it's now step number 3, she came back down. So here, yes, it went up. And here also, yes, it went up. But which of them, A or B, mentions staying up for a while? Of course, it's graph B. He stayed up for a while, for some minutes. So this is graph B. And if you want to make sure, you will find that in step 3, she came back down. So the correct answer is graph B. Kenan is a sprinter on his school's track team. During race, his breathing rate increased until it is much higher than his resting breathing rate. His breathing rate remains elevated. So again, it increases. First it increases and then it remains elevated until the race is over. Once the race is finished, Kenan's breath rate gradually returns to normal, so it decreased again. So take care. It elevated. First it increased. First, number 1, it increased. So this is number 1. In both graphs, it's correct. Both of them increased. But which of them mentions remains elevated? Remains elevated and stayed high. Means stayed high. So this is 2. And the last step is going back again. So this is the correct answer because it has the part of remaining elevated. Excellent job. We are done with module 5, alhamdulillah. Please, if you have any questions, let me know. I really hope you enjoyed the second video. See you inshallah in the last and the next video. Thank you so much. Have a nice time. and bye bye.